Hello, I'm the Dapper Minecrafter, and I made a redstone calculator in Minecraft. But in order to understand it, you have to learn how binary works. Binary is just a different way to write numbers, like 17 or 21. To understand it better, I'll explain a little bit more about how base 10 works, which is the numbers we use normally. We all know that there's the ones place, the tens place, the hundreds place, the thousands place. It just kind of goes on. There's a whole bunch of places. Ones, tens, 100, 1,000, 10,000, and the number you put in here means this times this, plus this times this, plus this times this, plus this times this. So it's 1,000 plus 300 plus 20 plus 9. But we would just write that as 1,329. But notice the pattern here. This here is 10 to the 0 power, 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power. And there's nothing special about 10. The only reason we use it is because we have 10 fingers. So if I make a new one that says 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, and 2 to the fourth power, dot dot dot. Now we only need the digits 0 and 1 to represent any number. So this is a value of 1, this is a value of 2, this is a value of 4, this is a value of 8, and this is a value of 16, dot dot dot. So 1 would be 1, 2 would be 2, 3 would be 2 plus 1, 4 would be, I have to move that over, and so you have 1 plus 2 plus 0, 2 plus 1, 4 plus 0 plus 0, 4 plus 0 plus 1, 4 plus 1 plus 0, 4 plus 2 plus 1, 8, 8 plus 0 plus 0 plus 1, and so on. And you can represent any number like this. It's just easier to make machines that handle it because there's only on and off, 1 and 0. To add numbers in binary, you take the first number and you take the second number and then you add them together. 1 plus 0 is 1. 1 plus 0, 1 again. 1 plus 1 is 2, which is 1 times 0, so 0 here and a 1 here. 1 plus 1, same thing. 1 plus 1, same thing. But here's the problem. 1 plus 1 plus 1, 3, 1, 1. 1 plus 1, 0, 1. So this is telling me that 1 plus 4 plus 8 plus 32 plus 64 plus 2 plus 4 plus 16 plus 32 is equal to 1 plus 2 plus 4, 8, 16, 32 plus 128, which in base 10 is, I'm not sure, is a whole bunch of crazy numbers. But let's think about an easy situation. We're adding two 1-bit numbers, so 1 or 0, meaning there's 4 options. 1 plus 0, 0 plus 0, 1 plus 1, 0 plus 1. And if we write out what they all equal in binary, we get 0, 1, 1, 0, 1. And so an easy pattern to pick up is if they're both 1, we have to carry it over. So if we do this with logic, and we make this magic gate, and it has 2 inputs, it can have an output. These will both be a 1's place, and this output will be a 2's place. And the 2's will be on if both are on. And the 1's place, we can see, is on if only one of the inputs is on. So it can have a 1's output too. And there's no way to get to the 4's place. So we can represent our gate as having 2 inputs, both are 1's. Then we use the fancy XOR gate I showed everybody in the last video. And this is the 1's output. And then we can just kind of scoot that line over there. And then we can also use an AND gate to see if they're both on. Actually, I'm going to use a different color to represent the 2's place. So then this is 2's. But what if we want to add more than that? Well, then we'll need a 2's and a 2's. And so then we can XOR them together. And then we have another 2's place. But wait, we have 2 different 2's places? So then we have to do everything again. So I'm going to get rid of everything and start over. You have a 1's input and a 1's input. They go up. One kind of jumps over the other because that's how we have to do it. That's okay though, because Minecraft is 3-dimensional, and so we can do that quite easily. Then we use an XOR gate, and then this is the 1's output. But then we have the AND gate to see if they're both on. Oh, oops, that's not good. Which then goes to the 2's place. But then we also have a 2's input. That's kind of messy, but I'll leave it like that. And then we'll XOR them. But now we have another 2 inputs. So I'll just kind of scoot them over to each other. I'll jump one over the other. And then I'll split it again. And now we have another XOR gate. And then this is the final 2's output. Meaning we're taking this 2 plus this 2 plus this 2. If these two are the same, then nothing happens. So if this is on, it's on. If it's off, it's off. If only one, and then this one, it's off. And there's a whole bunch of logic, but you can run through it and verify it works. And then we need an AND gate. this one needs an AND gate, and I don't want to use pink because now we're moving on to the next color. I'll use bluish. And since we're only adding 3 numbers, they can't have another place, like these can't both be on. So then we have the 4s. And now the pattern just kind of repeats. So I'll just quickly draw out what the 4s will look like with a full gate. And then we have the 8s. You can have this pattern continue out for as long as you want, and the complexity increases linearly. And you can verify that this pattern will add numbers in binary. Okay, bye.